Hello sir, greetings of the day. This video is the continuation of the part 1 which has recorded for the mini project review 1, and now for this review 2 I have already completed the total model of the automatic transmission with 12-speed gearbox configuration, and as discussed in the review 1, I have done with the engine model. New share. So this is the engine model, and in this I have considered a 2D lookup table which gives the engine torque and speed parameters, and then share. So likewise I have built the Simulink models for the engine, gearbox, transmission, and the vehicle model, and I have given the inputs of throttle and brake from the drive source. New share. Okay, so in this signal builder I have taken the passing maneuver, full throttle, hard braking, coasting, and gradual acceleration. So when we change the parameters here, the activity group, so the throttle as well as the braking parameters gets changed automatically. So this will be helpful to set various maneuvers. And coming to the manuscript, so this is the manuscript that I have written. So coming to this, the abstract and followed by the introduction and the gear ratio. From here the real procedure of the experiments will start. So in this gear ratio I have explained regarding the gear ratio, fuel efficiency, and the power performance parameters with respect to the transmission, and I have considered this 12-speed gearbox by benchmarking it to a 10-speed automatic transmission, and the result what I got in this method is we got the equal shift intervals between the gear shifts. That is, if you look into this diagram, so the step size between gear 2 and gear 3, 3 and 4, 4 to 5, 5 to 6, 6 to 7, and so on till the last gear, the intermediate shifts is almost all it is uniform. So this gives the pleasant ride characteristics of the vehicle. And then coming to the gear step ratio, so in order to attain this close gear steps shift intervals, so we have to consider the gear step ratios. So for this the gear step ratios I have increased the first gear step and lowered the final gear step. So I got a spread of 9.196 with a final drive of 2.614, and these are the intermediate gear steps. So if we observe it closely, the gears are having a larger step at the beginning, that is at the lower gears, and they are having very close step ratios when they are going to the higher gears. So this resembles that when the vehicle is moving at a higher gears, then the shift intervals is almost all nearly closer. And it was also observed that the gear shift time between one gear to other gear is almost all around 142.315 milliseconds, and this can also be shown from the um, graph plot which I got. So these are the shift intervals between this 12-speed gearbox and this 142. Suppose I have considered a gear that is shifting from 10th gear to 11th gear. So the time that is taking between to shift between 10 and 11 is this one delta t we can find here, that is around 142.315 milliseconds. So likewise the remaining parameters, the remaining gears can also be shifted within a very less time of around 140 milliseconds. So, and then coming to the total model, we have achieved all these things by building the Simulink model. So in order to build this model, we do require the engine subsystem followed by the vehicle subsystem and then the transmission system. And as we are focusing mainly on the gearbox configuration, so in order to get the gearbox of 12-speed configuration structure, so a gearbox structure plays a crucial role in the in this. Suppose let us take a look over this table. So in this model, the gear train consists of three planetary gear sets, 4 clutches and 2 brakes. The 4 clutches C1, C2, C3, C4 and the 2 brakes B1 and B2. The 12 speeds are achieved by this using this, and its operations are shown here. And the structure of this gear train connection is such that the input switches between C1 to C4 and is divided into two major patterns of shifting elements. As you can see, this C3 and C4 are of a similar pattern, whereas the C1 and C2 are of a different pattern. So totally this C1 to C4 region is split up into two major patterns, and the number of decelerated rotations in the input through the ring gear and by means of turbine rotations being input through the planetary carrier to the double planetary gear with a constantly fixed sun gear. The turbine rotations will act as a base through the connecting and disconnecting the clutch and brake with each member of Ravigner's planetary gear set. For the reverse gear, the rotations input fed into the rear sun gear is reversed through Ravigner's planetary carrier by engaging B2, and the output is obtained through the output shaft. And finally, the power performance of this is also calculated as well. So let me share the graph plot from this. Okay, so here the this is the plot between the vehicle acceleration and the time, and here the blue line shows the gear shifts, that is the optimized transmission torque, and the brown line represents the turbine rotation. And here the torque converter fluid, let me share one more thing here. Sorry for the delay, small moment. Okay, so in this figure, if we see the blue lines represent the torque converter fluid performance, and the brown line represents the rotation of the turbine. So the torque converter fluid performance and the engine control has been optimized to obtain the best acceleration feeling. The launch of the performance has been achieved by lowering the first gear ratio. The closed gear ratios at the intermediate speeds further improve the accelerating power in terms of passing accelerations and high speed regions. So this is all about the uh, model what we have developed in this. So the final conclusion of this mini project is the new 12-speed automatic transmission was developed for driving pleasure, quick and smooth gear shifts, and it was observed that the gear shift timing takes around 142 milliseconds, and also power performance is better optimized at good acceleration feel by low gear setting. And this model can also be utilized in advancing any of the automatic transmission systems of passenger car segments. So thank you for providing me opportunity to work with you. Thank you, sir.